All right, welcome back in. We are going to be just giving you a brief introduction to dimensional analysis today. There will be some separate videos just to talk about specific cases in which you're going to be using dimensional analysis. But basically, the idea of dimensional analysis is that you're trying to cancel out units to be left with whatever unit you're looking for. So let's just say that you're given concentration and the answer choices are all in grams. Dimensional analysis is just the way that you'll cancel out units to get through everything to be left with grams, if that makes sense. So we're mainly going to be using Gen Chem as the explanation for how this works, because that's going to be the main place that you're going to be using dimensional analysis, but it's going to be all over the place. You can use this even in other scenarios that's not necessarily just Gen Chem, where you're also going to be doing some stoichiometry. That's like those, for example, if there's like 6 glucose molecules that interact with something else, that 6 number, that's the stoichiometry. Dimensional analysis are the units, like grams, concentration, moles, all that sort of stuff. So basically in Gen Chem, we're obviously going to have to do this quite a bit, but this is something that this idea of canceling out units to be left with what you want is something that you might also need for random problems in physics, that maybe there's not necessarily a specific equation that you're using, but the units are the hidden the units are basically telling you exactly what you're supposed to be doing. So even though you might not know what equation you're supposed to be using per se, if you just look at the units and cancel things out, you'll be perfectly fine. Like, for example, there was one question on my exam that they gave me CFU per minute, and then they just gave me time in the question. And they were like, how many colony forming units are made? As you can see, if I just multiply, like if it was 6 seconds, I can just multiply this by 6. I would have to convert minutes to seconds. I think, like, obviously you want everything in the same unit, but once we have it in minutes, let's just pretend that it was minutes. We cancel out the units and we're left with CFU as our remaining unit. Right? That's basically the idea here with dimensional analysis. But like I said, the main subject that we're going to use to talk about that is Gen Chem. So in Gen Chem, I actually have a little bit of a flow chart that will make 99% of Gen Chem dimensional analysis significantly easier. So basically, I'll just write it out that we're going to be taking density. I'm just going to write out the full thing first, and I'll write the conversions really quickly. We're going to go from density to mass to moles to concentration. Sometimes you might see concentration expressed as a density because density is measured in grams per liter. Mass is measured in grams. Moles is just mole. And then concentration on the MCAT is pretty much always going to be molar, a molar concentration, which is the same thing as moles per liter. Right? You might see a concentration expressed as like 60 grams per liter. That's technically a density. You don't need to necessarily worry about the differences between the two. But basically, this figure is going to tell you exactly what you're supposed to be doing. Right? So in order to get from density to mass, we're going to have to multiply the density by the volume. In order to get from mass to the number of moles, we're going to have to divide the mass by the molar mass. And in order to get from moles to concentration, we're going to have to divide the number of moles by the volume. Right? Again, we're going to do some examples with this, basically going both directions. But let's just pretend we need to go the opposite direction. So if we're trying to go from concentration to moles, all we have to do here is multiply the concentration by the volume. If we're trying to get from moles to mass, we just have to multiply the number of moles by the molar mass. Just doing the opposite of what's on top. So for those of you who are guessing at home, if we're trying to go from mass to density, all we have to do is divide the mass by the volume. Right? So this is basically just a little bit of a flow chart to make a lot of that dimensional analysis significantly easier. I'm going to add in one thing right here. I'm going to add this just in orange because this is not something that we're going to worry about right now. This is going to be, we're going to have another chapter that's just dimensional analysis practice in specific scenarios. So this is something that's especially important if you were to have like a limiting reagent question. You basically are going to have to do what I'm going to call a stoichiometry check. We're not going to do any practice problems in this video that we're going to have to do. This is just practicing with dimensional analysis. This is going to come with a whole bunch of practice problems for dimensional analysis. But basically, whenever we get to Gen Chem, just know that essentially there's going to be one extra step that's added when we're going to have to check on some stoichiometry. Basically, the way that I typically word this is imagine that whenever you're traveling left and right, that's like you're speaking one specific language. And that one language only applies to one specific molecule. So, for example, most combustion reactions, like if we're adding methane to oxygen, I'm not going to do the stoichiometry right now, but let's just say that they're like, hey, how many, if we give you theoretically half a mole of methane, how many moles of oxygen would also be needed? So that's what you would be doing stoichiometry for. You would start off with the moles of methane. You would convert that to moles of oxygen using the stoichiometry check. Now you're in the language of oxygen, and then you can just go to whatever, maybe they ask for the specific number of grams of oxygen after that. But that's going to make a lot more sense whenever we get there. We're not going to worry about it right now, so just kind of erase the last 30 seconds from your memory just for a short little bit. Okay, so here is this figure, and like I said, we're just going to do two quick little practice problems just to make this a lot easier. So the first practice problem that we're going to do is this one right here. Obviously, they're going to give you answer choices on the MCAT, but I'm lazy. I forgot to make answer choices, so my bad on that. But they're going to give you this first answer choice right here. So I'm just going to write out the variables that you were given. A student dissolves a mass of 5.85 grams of NaCl. I'm going to go and round that to 6. That's a really small rounding error, so I feel comfortable doing that. So we essentially have a mass of 6 grams of NaCl, which has a molar mass of 80, I'm going to round that up to 60 as well, 60 grams in every 1 mole. I like to write a lot of my units like this. Instead of just grams per mole, I like to literally write grams over 1 mole. This is basically just showing you that there's literally 60 grams in every 1 mole. It's just going to make what we're about to do with dimensional analysis a little bit easier to actually see. In water, and that is going to make a volume of 500 milliliters. We need to convert that to liters, which is going to be 0.5 liters. That's those unit conversions really quickly, just like that. That's the scientific, the SI prefixes with milli, penti, all that sort of stuff. You don't need to know penti, but that's all stuff that you need to know like the back of your hand. I do have a quiz that 2 quizzes that actually test that in my web app. You can find that linked on my website, linked in the description. That's basically just going to say like, hey, how would we go from meters to nanometers? Or how would we go from nanometers to meters, back and forth? That's something that you need to know like the back of your hand, that you can just look at this and know that that's immediately half a liter. Okay, so this is everything that we are given, and notice that we are looking for molarity, right? So I'm going to circle this in green. This is where we are trying to get to. And we started off, I'll circle this in yellow. We started off with mass. They did give us some of the like molar mass and volume, which is going to help us get from point A to point B, but these are our starting points, right? Okay, so the first thing that we're going to do is we're going to write the mass. We have a mass of 6 grams of NaCl. And in order to get to moles, we are going to have to divide this by the molar mass. So we are going to be dividing this by 60 grams. Right. Another way, 60 grams in per mole. Like I said, another way that you can do this, if you're really thinking about canceling units, basically you're just going to multiply everything, but you need to orient this relationship right here so that we're canceling out grams. So 1 mole is 60 grams of NaCl. So notice that whenever we multiply these two things together, we're going to cancel out the grams of NaCl and be left with moles of NaCl. So if we just write that, we're left with 6 over 60 moles of NaCl. Which, again, notice that we're also just dividing it by the molar mass of 60. It's the same thing. But I think doing it this way is going to be more visually easier to see exactly what we're doing here with canceling out units. And this fraction is just going to cancel out to 1/10, which is just 0.1. So we have 0.1 moles of NaCl. Then from here, notice that we are now at moles, and we just need to get to concentration. So all we have to do from here is we take 0.1 moles of NaCl, and in order to get to concentration, we have to divide this by the volume, which is 0.5 liters, 0.1 moles. What am I doing here? This is 0.5 liters of solution. And notice that we're going to end up with the unit moles per liter, which is the unit of concentration, right? We have found the unit that we're looking for. So we just have to divide the number of moles by the volume, and that's going to give us concentration. 0.1 divided by 0.5 is going to simplify to 0.2. If you think about 1 divided by 5 is 20%. 20, any way you want to think about that, that's why I got 0.2 that quickly. And this is moles per liter of NaCl, which is the exact same thing as just saying 0.2 molar NaCl. You also might see concentration put into brackets. That's saying the exact same thing. This is the concentration of NaCl. But yeah, okay, so that's the first example. That's basically just a much easier way to visualize how we're canceling out these units. This has explicitly written out every single Gen Chem dimensional analysis problem that you'll probably ever have to do, unless they've given you units that are not listed here. But for the most part, probably 80%, if I had to guess off the top of my head, of dimensional analysis problems will basically follow this exact same format, that we're given one side and we have to go to the other. And like I said, whenever we get to more complex problems like limiting reagent problems, that is something that we'll cover, but we're going to basically be using the exact same little diagram. So now we're going to do a slightly different problem. We're going to do this problem right here. Okay. I'm actually going to change this to make this slightly more difficult. We're going to do 2 liters. 2 liters of solution. Okay. So in this problem, just writing everything out. So a glucose solution has a concentration of 2 molar, right? Okay, so this is where we're starting. We are starting over here. Just to write this out, our concentration is equal to 2 molar. It has a molar mass of 180 grams per mole. That was an ugly M. A molar mass of 180 grams in every 1 mole. Like I said, if you just write it out physically like that, that might help you actually see the units more easily to know how to cancel them out. And then assume the volume is 2 liters and then it doesn't change. That's great, whatever. And they are asking for density. That's where we're trying to go. We're trying to go from the right all the way to the left. Right, so if you just follow along with the arrows, this is pretty easy, right? All you have to do is just start with the concentration. We have that 2 molar concentration. In order to get to the number of moles, remember that concentration is the same thing as moles in every 1 liter. So notice that if I want to be left with moles, I have to multiply this by a volume. The volume that they gave us is 2 liters, so that we cancel out the liters and we're left with moles. That's the whole idea of dimensional analysis, right? Notice that I've literally told you just multiply by the volume right there. So this is going to give you 4 moles of what is this? Glucose. That's the molecule that we're looking at. 4 moles of glucose, and then from here, all we need to do to convert this to mass is multiply it by the molar mass. And molar mass is grams per mole, and we're trying to cancel out moles this time, right? So if we multiply this by 180 grams per mole, I don't know why I sometimes write my ones different than other times. Notice that we're going to be canceling out moles of glucose here, and we're going to be left with grams of glucose. So 4 times 180, 4 times 18, 2 times 18 is 32, times 2 again is 64. So we have 640 grams of glucose. And the last thing that we need to do is get this to density. And in order to get this to density, we just need to divide it by the volume, right? Because the units of density is grams per liter. We already have grams. We just need the liters, which is 2 liters. So 240 divided by 2 is roughly going to give us 370 grams per 1 liter. And that would be your answer, 370 grams per liter. Right. So that's the long story short of how you can quickly do a lot of dimensional analysis. We're going to do one more problem really quickly here in a second that basically shows you what exactly is happening in dimensional analysis, that we're just canceling out units. We're basically going to be doing an example that doesn't involve anything listed here. But basically, that's the long story short of how to do dimensional analysis. You're basically just canceling out units in order to get to where you're trying to go, right? If you're starting out, you just have to identify what you were starting off with and then basically just slowly one by one cancel out units to get to where you're trying to go. This is why it's really important that you have a really good understanding of those SI prefixes like nano, micro, and all that sort of stuff, and that you memorize what the units of things are, because knowing the units is going to make it significantly easier to do dimensional analysis. A lot of math on the MCAT is simply just dimensional analysis problems. It's not actually applying equations. There's going to be a lot of equations, but I'm saying that a surprising amount of MCAT math problems can be solved just by understanding units and dimensional analysis. So let me clear this off and get our final practice problem up. All right, so here's a practice problem that's pretty similar to kind of what I was talking about earlier. So basically in this problem, maybe you get the question, they give you this table in the passage, and maybe there's other, there's like a Petri dish A, Petri dish B, whatever. There's experimental groups, but maybe that you just have a question that says, how many colonies are in the control? Something like this. How many colonies are in the control, right? So basically you want to identify, so basically you want to identify in this table, where are the colonies? Where basically where are we going to end up, right? So notice that colonies is right here. And this is colonies per cubic meter, so that's not necessarily what we're looking for. So basically from here, I'm just looking, is there a way that I can cancel out this cubic meters? And there is. I gave you Petri dish volume right next to it. So notice that all we have to do here is, if we're just trying to cancel out units, we have colonies per cubic meter. If we're trying to cancel out these cubic meters, we just have to multiply this number by cubic meters. The cubic meters is going to cancel out, and we're going to be left with colonies. So basically, we just have to multiply these two numbers together, and we get our answer. I gave you absorbance just to kind of throw you off a little bit. But basically, that's all we have to do here. So just to show you in that with the actual numbers, we have 4 times 10 squared. This is colonies in every 1 cubic meter. And we are given a volume of 1.5 times 10 to the negative 7th cubic meters. I'm realizing that cubic meters doesn't really make sense for Petri dishes. We usually measure those in like area rather than volume, but that's okay. I'm hoping you just understand the point that we're trying to get at here. So basically we are canceling out these units. We can ignore those at this point, and we just have some scientific notation math to do here. So 4 times 1.5, that's going to give us 6. And then whenever we're multiplying 10 squared times 10 to the negative 7th together, we're going to be adding those exponents. Whenever you're multiplying scientific notation, you're going to add the exponents. So we have times 10 to the second plus negative 7, which is going to simplify out to negative 5. And that's it. Notice, super simple, super straightforward, not difficult at all. All you have to do is basically just look at how you can cancel out units to get whatever unit you're looking for. That's it. That's dimensional analysis. Like I said, we're going to do a whole bunch of practice with this. So even if you are a little bit confused with it right now, I highly recommend, if you're watching this on YouTube, signing up for my course. That's going to really help you out a lot just with explicit practice over these things. But obviously, if you're watching this in the course, which I'm going to guess probably 95% of you are, don't fret. We'll be doing a whole bunch of practice just to make sure that all of the different ways that this might show up are solvable in your own little noggin there, that you're not going to be overwhelmed by things. I promise once you kind of understand this idea of canceling out units, you're going to be perfectly fine for the exam. So that's it. Feel free to sign up for updates on my course whenever it's released. It's possible that if you're watching this, it's already been released. But sign up for updates in the description to this video. It's going to make your life a little bit easier to know whenever I've released something, another content workshop, or I have also still released a whole bunch of free resources. I'm trying to make a new Anki deck at some point sometime this year. Also have some other things in the oven that are cooking up that will release, and you'll get updates over if you sign up for updates on my website. You can just scroll to the bottom and there's a little update form right there. But yeah, long story short, appreciate you guys watching. Good luck with your math stuff. Hopefully I'm seeing you in the content workshop so that we can work through actual practice with this.